project scientist and environmental management and policy research institute, Bangalore. Sir has very nice details, actually nice briefings. Dr. Narayan has masters in remote sensing and GIS from Vidyasagar University, West Bengal. His doctorate in remote sensing and GIS at VU, Indian Institute of Technology, Kharagpur, and focused on forest health monitoring and proceeding using hyperspectral data for effective geo-environmental planning and management of iron ore mining belt, Jharkhand. He worked as a postdoctoral fellow, PDF in ISRO, Birla Institute, Technology and Science, Pilani, Goa campus. He published 17 high-impact factors articles in peer-review journals and 1 book and 4 book chapters. Dr. Narayan has joined currently. He is working in air quality modeling and forecasting for Karnataka. Such a nice detail sir is having. So let's together learn and make this session as successful. Now I will call Dr. Narayan Kayat sir for a dais. Sir, mic hand over to you, sir. Thank you.
Thank you, sir, for introduction. Today I am talking about the short-lived climate pollutant in Karnataka. Basically, this project sponsored by US, and this project actually objective is the basically monitoring the short-lived parameter and prepare the mitigation technology in Karnataka. So that project I will show Karnataka situation of all pollutant. Which district is the highest contributor and lowest contributor, and also economic and cost benefit analysis and mitigation technology, so that we can use for the reduction of the pollution in Karnataka level. So why we are calling to the short-lived parameter? So because of the after carbon CO2, all parameter like black carbon, methane and tropospheric ozone and hydrofluorocarbon basically a very big effect. You know, all are basically effect to the health effect, and like lot of cancer disease, lungs, skin disease was coming air pollution. And so please next slide. Okay. So so what is the pollutant we are monitoring? Shortly, basically 4 parameter. Black carbon is the part of the PM 2.5, and methane also basically greenhouse parameter, and tropospheric ozone also greenhouse parameter, and also HFC hydrofluorocarbon, this is also greenhouse parameter. So those are parameter very highly impact to the climate, ecosystem, agriculture, all health impact. And go to the next slide. So what are the source of the SLCP? So lot of source is there. You can see this is the industry source. A lot of industry, they are polluted much more black carbon, and also some waste burning, and also transportation sector. And also you can see this is the forest fire, and another is the agriculture crop burning, and lot of sources there. The different sector is contributed to the SLCP parameter. And so impact climate change, you know, this is all our temperature increase and like rainfall pattern change, all are happened in Karnataka due to the climate change and air pollution. So and health impact, all are, you know, the lot of tropospheric ozone is the highest contributor, and black carbon is the effect to the health. Basically lot of disease is due to the black carbon emission, and health effect is the very high impact. And also ecosystem, you show a lot of ecosystem effect to the like air pollution, and also economical loss. Agriculture production also losses due to the agricultural production, economic also losses. So next slide. So what is the black carbon? Black carbon is the scooty, basically black material from PM 2.5. It is very high impact after CO2. It is called for basically second highest contributor of the emission in after CO2. And most of the source are, you know, all are waste burning, forest burning, and also agriculture burning, and also industry source, and another lot of sources is there, and after according to our IPC data set, India and China highest contributor of the black carbon in world actually. So next slide. So coming to the technical part, I just introduce what is the black carbon methane, and we are working. So this is sector-wise black carbon emission inventory. We are preparing for sector-wise. We are using basically IPC guideline methodology. IPC basically prepare for internal government panel basically. They are prepared for climate change, all rule and regulation. So based on their methodology, we are prepared in Karnataka level how much contributor. You can see this is the different sources. Energy source almost 56% is the Karnataka black carbon sources, and another is the like stubble burning and forest fire is the almost 60%. Another also like another sector also. I just focus that pie graph is a lot of different another sector also, like another sector is contributor in Karnataka. Next slide. So first I am coming to the black carbon emission inventory in Karnataka industry sector. So you can see this is the map. We are consider 5 industry like brick kiln, steel industry, thermal power, and also cement industry, and also another sugarcane industry. So those are, you can see, this is Karnataka. We have generated based on the IPC and based on the model based, we have generated first time 1 by 1 kilometer grid-wise emission inventory based on the GIS. And you can see this is the pink color. I just focus to the Bangalore area. You can see this is the pink color, all our industry area, highest emission is produced, basically black carbon in Karnataka. So based on our data set, we calculated based on the IPC, and also we calculated like which industry highest contributor in Karnataka is black carbon. You can see this is coal-based industry is the highest contributor. Then like sugar cane and another industry also. This is pie chart actually showing this is the percentage of the how much percentage is the basically which industry is contributing in Karnataka. This data actually prepared for 2022 baseline, and projection data also. And this is the district-wise bar graph. So we can also identify which district is the highest contributor and lowest contributor in Karnataka. So you can see this is the Bangalore urban and Mysore and Ballari, all are Udupi, all are district is the highest contributor of the black carbon from industry sector. Next slide. So I am coming to the one subsector in industry, brick kiln. So black carbon emission inventory from brick kiln sector in Karnataka. So you can see this is the all our brick kiln has produced lot of black carbon. So we have particularly monitored we not monitoring the brick kiln area emission also. So first we are using machine learning method. So identification of the brick kiln, where is the particular located of the brick kiln. So that's why we are using satellite data to identify the basically where is situated the brick kiln. So you can see this is the point, all our red point map. Basically brick kiln location. We have identified like 5,000 plus brick kiln in Karnataka, and based on the machine learning method. Those data we are using for the put the model, GIS-based model for grid-wise emission inventory, black carbon emission inventory from brick kiln sector. So all are also we are collected the district-wise brick kiln production data and emission factor, and a lot of parameter is required for grid-wise emission inventory. Preparing a lot of parameter is required. So we are prepare all parameter and calculate the black carbon from brick kiln sector. You can see this is the Kolar district is the highest contributor in Karnataka brick kiln. And previous slide. So Kolar district, you can see this is red pixel, basically highest contributor of the black carbon they are produced because of those area basically highly located of the brick kiln, or 3-4 brick kiln are located, and also a lot of area also covered, highest area also covered. So and production also high those area also. That's why is the red area is the highest contributor. This is the grid 1 by 1 kilometer grid we are prepared, and you can see this is the location also, which location particularly produce the highest black carbon from brick kiln sector. Based on our data set, we have identified which district is the highest contributor. You can see Kolar district is the highest. Next is the Darbhanga and another all Shivamogga. All our districts are basically highest contributor from black carbon emission in Karnataka. Next slide. So after I coming to the like different type of analysis, we are using Liv model. Like Liv basically using energy model. So we are for future projection. If our emission is continue, like going to the like we are preparing last 7 year data set, and 7 year data set base we are prepared the annual growth rate. Annual growth rate base we use for the Liv model for the future projection. Yeah, like similar way going the emission, how much is going to the like 250 in 250, how much emission is going. So you can see this is Karnataka, almost 70 metric ton is going 250 based on the our projection data set. And after we are preparing the mitigation technology, which mitigation technology can reduce like black carbon from Bitcoin sector. So a lot of technology is there, zigzag technology, BK technology, and another technology is there for Bitcoin production technology. This is there. So we are calculated which technology, this is the cost benefit analysis that side, which technology particularly effective and also reduce the pollution also. You can see this is the VK technology is the very effective, useful, and cost also lost. Low cost and also effective pollution also reduce. And after the economical analysis, we are using economical data to health benefit analysis. Mostly Brickin area, lot of people are working. They are affected to the lot of disease like health impact, health effect. So like lungs and cancer disease, all are basically coming to the pollution level. So we are preparing projection based on our data set. If I reduce like 10% emission in 2030, how much health benefit value is coming. And also you can see this is the 2030 and 50 we put it in graph in Excel sheet. So you can see this is the economic value also reduced and health economic value also. So that data government can use for the future projection, future planning, or mitigation technology for purpose. Next slide. Coming to the another sector, black carbon emission inventory from industrial thermal power. You know, all are thermal power. Karnataka located total 6 thermal power. They are every day produce lot of black carbon. So you can see those are the point, red point, and basically thermal power location. Another one point is the NTPC power plant. This is the highest contributor in Karnataka. This is central government power plant. Those data we have calculated for based on the coal consumption data and emission factor. We have calculated the like thermal power, which thermal power is the highest contributor in Karnataka. And you can see this is the NTPC power plant is the highest produce and black carbon in Karnataka level. Based on the data set, you can see, I just focus on Google map. You can see this is the thermal power chimney is located. That area we have projected the grid-wise emission inventory. Red area basically showing highest emission because of those areas the chimney is located, emission is coming. So based on the data set, we prepare similar way like business as usual scenario and reduction scenario and mitigation technology for Karnataka level. Next slide. And BC emission from cement industry, it is basically a cement plant location based on the government data set. KGS provided, basically Karnataka GIS, they are provided data set. The cement, one cement plant, there are lot of cement industries there. We only put it the cement plant location. Based on the our data set, only some data is government data is available. So we are only consider government data. So after we calculated which district is the highest contributor and lowest contributor, we have identified. You can see those are district is the Barga we also provided. And also similar we prepared the mitigation technology, which can technology can reduce the like black carbon from cement industry in Karnataka. Next slide. Another slide is like BC emission inventory from sugarcane. You know, all are basically sugarcane also lot of produce like black carbon. So we collected the sugarcane location, industry location. All are pink color, basically located. Located this map actually located the where is the particularly sugar industry is located. Based on our data set, and we calculated like based on the emission factor and another factor, we put it to the model for generated for district-wise emission inventory. So you can see this is the almost Belgavi is the highest contributor of the sugarcane industry, and also emission also produce highest level. And based on the another district also Bhagalkot, Vijaypura, all our district is the highest contributor sugarcane industry. And based on the similar way, we are analyzes the projection by 250 and reduction scenario also 250, and also mitigation technology. Those technology can reduce to the black carbon in sugarcane industry in Karnataka. Next slide. And coming to the another big sector is the transport sector. You know, lot of black carbon produced like transport sector is the biggest contributor. So all our vehicle basically emitted like diesel engine vehicle, they are emitted lot of black carbon. So we are calculated like vehicle wise, which vehicle basically highest contributor in Karnataka. Like you can see, this is tractor and another, this is pie graph. You can see the tractor and basically highly emitted like black carbon in Karnataka. And another you can see also like another bus, two-wheeler, four-wheeler, all are we are putted. We are using a data set from Government of Karnataka Bahan Parimahan data set. We are also analyzing like 7-year data set. So you can see this is the black carbon emission inventory in Karnataka, 1 by 1 kilometer gridded. So you can see this is the, we just focus to the like Bangalore urban area. You can see red pixel area, basically highest black carbon black carbon emission, because this area is the connectivity of 2 and 3 road, and also population density also high level. So their connectivity 3-4 roads, that's why they're coming to the black carbon in Bangalore urban area also. You can see also Karnataka full map on yellow line. This is the highway. Also highest highway line. So it is also provided like highest emission in Karnataka black carbon. Based on the data set, lot of emission factor and coal consumption data, and also vehicle wise we have calculated. So which district is the highest contributor? You can see this is the Bangalore urban is the highest contributor, because of vehicle count and all are highest level. And also Belgavi and Tumkur and Hassan and Vijaypura, all our district is the highest contributor of the black carbon from transport sector. Next slide. Based on our data set, we have analysis also another year, 2017, 18, 19, 22, and combined the all data set and one graph. You can see that side graph, actually which district is the highest contributor. You can see all data we have combined one graph, like 6-year data. So you can see this is the Bangalore urban highest contributor, and based on the data set, we have projected the future scenario based on the vehicle wise. So you can see this is all our scenario by 250, and based on our model based, it is almost 160 metric ton is coming like highest emission in Karnataka tractor and another like vehicle. And based on our data set, we have prepared the mitigation technology, which can those are the mitigation technology can reduce the black carbon from transport sector also. And third graph we are prepared from reduction scenario. So reduction scenario basically telling the how much is reduction is required every year. So we put it like based on our data set, we put it like every year we can reduce 2% or 3%. It will be coming like reduce to by 250 by 3 metric ton is coming 250. If we reduce like black carbon from transport sector. And another we coming to the like economic analysis. This is required. We are using currently converting to diesel to electric car. So this is two-wheeler analysis, diesel engine to electric car convert. If I like converted in 2030, how much benefit is government is benefit, economical benefit is coming. That's why we require for economical analysis. You can see this is the almost 2023 baseline data, almost 48,000 per kilometer per year. We can calculate it. After you can 2030 almost 1 lakh per kilometer per year we can benefit if we reduce the pollution. And that side is the Excel basically cost health benefit analysis. Most are the like they all are affected due to the transport, and based on our data set we have also calculated the health benefit analysis. You can see per health benefit analysis currently is showing like 7,000 something is per economic based line. If I reduce, it is almost coming to the defined year 250 per economic value per person per year per kilometer. So this is the fully economical analysis. Just next slide. So I am coming to the another sector, cooking and heating. You know, you are using LPG and biomass and kerosene for cooking purpose, and there are lot of black carbon. They are source of the black carbon. So we are black carbon emission inventory from biomass and kerosene. You can see this is the Excel graph. On map, you can see this is the pink color. I just focus the Bangalore urban area. So you can see this is the Bangalore urban. Pink color is the contributor of the LPG based emission, because this area is the populated density, produces a lot of black carbon from those areas. Based on our analysis, we are district-wise data set, which district is the highest contributor and lowest contributor. And after we are also preparing the mitigation technology, where those are the technology we can use for reduce like black carbon from cooking and heating sector. Next slide. So after we are coming to the projection scenario, but you can see the PS2 sector projection business value scenario projection is going increase, but in this case you can see this is the projection scenario is a decrease. Anybody tell why is coming this the decrease trend? Any idea? So currently we are stopping, like that's why the future projection also reduce level. And similar analysis, the cost benefit analysis, they are basically using like once they are affected of the due to the cost benefit analysis. So if I reduce, how much the benefit is the government as well as the health benefit. We can reduce like in 2050 can reduce the health economic value. Another sector is the agriculture burning. So you know Karnataka is a lot of very small amount agriculture burning, but not Punjab and Haryana type, but Karnataka has is burning. Our government is showing like so we are black carbon emission from agriculture is burning. So lot of parameter is required, like we are first scatter grid data, forest fire and agriculture burning data set. So we are only extract the agriculture area burning. That type of map or defining here I put it the agriculture burning location. Red color you can see basically burning location. So based on our data set, we just focus to the one district grid. Burgi, Belgavi, all our district is the highest contributor of the agriculture burning in Karnataka based on the emission. And we are using also like multi-color simulation model for identification of the uncertainty analysis, because we are using satellite data and lot of secondary data. They are provided lot of error. So that's why our was how much accurate. So we are using multi-color simulation model for predict the error. So you can see this is the black carbon almost 28% is coming error due to the atmosphere components calculation error and data processing error and also satellite based data error. So after we are preparing the mitigation technology, you can see lot of alert system and lot of different technologies there. We can use those technology can reduce to the agriculture burning based emission, and that side is the cost benefit analysis. Next slide. And another sector you can see, this is the forest sector. Forest fire, forest fire also lot of produce the black carbon in Karnataka. So you can see lot of parameter is required for calculating the black carbon emission inventory from forest fire. So you can see this is the Uttar Karnataka is the located the basically Western Ghat part. They are produced the highest of the forest fire and emission also. You can see this is the red area also. You can see highest forest fire area, and based on our data set, we calculated the gradient wise emission inventory 1 by 1 kilometer. So that zoom map you can see, I just zoom the Uttar Karnataka districts, and you can see red pixel area is the highest contributor of the black carbon in from forest fire in Karnataka. Next slide. And coming to the pattern analysis, we are using two decade data, satellite data, put to the 10 analysis. You can see this is the every year pattern is changing, forest fire, so Karnataka level, and also black carbon produce also changing. And based on the data set, we have identification which district is the highest contributor. You can see Uttar Karnataka, Chitradurga, all our district is the highest contributor of the forest fire. And based on the data set, we have prepared the mitigation technology. So mitigation technology provided basically satellite-based monitoring. Lot of satellite is there, MODIS and also ESA, European Space Service, ISRO satellite also there. They can directly provided the burn area. You can directly, every day, every hour they provided the data set. You can directly monitor the Karnataka level also. And also alarm system is there. You can use alarm system based on your sensor base. And those technology we can use for the reduction of the black carbon from forest fire. And those are the future projection and reduction scenario also we put it. And also we put it uncertainty analysis. It is showing black carbon is showing 22% is coming error. Next slide. And this is all our secondary based, model based work. Coming to the another part, satellite based monitoring. So first part, we are based on the government sector-wise data set, secondary based data and GIS based data, and this methodology actually provided satellite based monitor. We can monitor also black carbon, methane and tropospheric ozone. Lot of satellite is there. Sentinel-5 is the ESA European Space Applications satellite. They provided every day air quality parameter like NOx, SOx, PM 2.5 and ozone. Every day 1 hour they provided data. You can download it Google Earth Engine and lot of knowledge of programming background. So you can download it, pre-processing and analysis pass you can do based on the satellite. And another also ISRO satellite and a lot of INSAT 3D also satellite. They are using ISRO satellite for monitoring the air quality and climate parameter also. And another also OMI satellite. OMI basically provided NASA. NASA also provided a lot of satellite. They directly monitor the air quality. Those data are freely available. You can download it your area and you can analyze it every day. And next slide. So satellite-based monitoring, I'm coming to the satellite part. So satellite-based monitoring, black carbon concentration in Karnataka. You can see we are prepared for every year annual average black carbon concentration in Karnataka 2018, 19, 20. Data is available to 18. So we are preparing every year. You can see this is the red area is the highest contributor of the black carbon in Karnataka, and blue area is the low black carbon concentration. So due to the lockdown period, you can see 2020 data. This is third map. Black carbon red pixel is vanished because of due to the lockdown period, and a lot of black carbon is reduced. So you can see map also, satellite also data showing due to the lockdown also reduced the black carbon concentration in Karnataka level. After the lockdown, it is increased trend also. Go to the next slide. So you can see this is the another year 2023 and 24 all data set is here. Also you can see this is the changing the pattern also black carbon concentration in Karnataka level. Based on our data set, we are processing of everything like lot of require supercomputer and web server and also high speed internet because of the lot of high volume data is satellite also processing lot of bias correction, atmospheric correction, and also pre-processing step also lot of infrastructure also required. And next slide. So why is the red color is the highest? So we have identification of which area is the red concentration. You can see this is the red area, some cement industry, NTPC power plant, and also some JSW energy plant, and also Bangalore urban, and also some transport area. So I just focus some area, so you can understand the why is the hotspot those area. And you can see also Bangalore urban. That side is the map. I put it to the animation map. So every year red pixel is increased. You can see only due to the lockdown 2020 other year, you can see this is the increased trend. Next slide. So we also collected like station-based data set. Karnataka have total air quality station is there, government 42 station. They are monitoring every day air quality, and we also collected the station data for the our compared to the satellite data also. So so we can validate our data also. So you can see those are the time series graph. You just showing the 6-year graph I put it for based on the all our air quality location point in Karnataka. So you can see only 2020 reduced, the blue color line is the reduced point. Another every year is the increased trend in Karnataka. And we also try to the validated our data, satellite data and air quality data. It is almost showing 0.7% 7% R square is coming, and every year we try to the validated our data set, and some error is coming due to the atmospheric component and data pre-processing error. Slide. And coming to the another sector-wise mapping. Concentration mapping in Karnataka. So this is the urban sector. You can see we just use KGIS land use land cover data and extract the only urban area. So where is the urban area is the highest contributor. You can see this is the red area. I zoom just Bangalore area. So red pixel, you can see this is the highest contributor of the black carbon concentration from urban sector also. Based on the data set, we have identification which district is the highest risk and lowest risk. You can see this is the Bangalore urban and Ballari, Kolburgi and Raichur. All our district is the urban sector is the highest contributor of the black carbon concentration. Next slide. And coming to the hotspot analysis, hotspot basically provided which area basically particularly every year hotspot, and cold spot basically provided the cold area. So we are using the satellite data like 7-8 year black carbon concentration data for analysis the hotspot analysis. So you can see this is the red area is the highly hotspot area in Karnataka black carbon concentration, and we are consider only 99% confidence level p-value we consider probability value 0.005 only, and those pixel we are extract. You can see this is the middle map is the basically overlay map. So because of the overlay we have identified the basically every year where is the emitted. So last map you can see the road red area are every year they emitted the black carbon in Karnataka level. So we have identified the 99% common area. This is all our common area. Every year they emitted the black carbon. So you can see this is the Vijaypura already 388 square kilometer area is coming, and also Raichur also 232 square kilometer is coming. So all are we are calculated based on our analysis actually. Next slide. So I completed my first pollutant, black carbon. I coming to the second pollutant is the methane. Methane actually biggest also called the greenhouse parameter. You can know methane also lot of sources, but agriculture is the highest sources. Like lot of 60 to 80% is produced from agriculture. After CO2 and methane basically responsibility 40% agriculture and other burning also, and industry also, some methane also. Lot of sources there, waste burning and waste dumping, and also livestock, also rice cultivation. All are the source of in Karnataka is methane emission. I'm coming to the one by one sector, so I can cover the all sector. Next slide. So this is the calculated, we have calculated like all over is black methane emission from Karnataka based on the IPC guideline. You can see this is the FLU sector is the highest contributor. FLU mean agriculture, forest and other land. So they are almost 64%, and another is the waste part, and another also energy and industry, another also like in part is provided. This is the pie graph, how much contributor sector wise. We provided the sector wise basically methane emission, and this is that graph is the basically provided the different another sector also. Come next slide. So methane emission inventory from agriculture sector. So we are consider three sector from agriculture. So one is the livestock, another is the rice cultivation or paddy cultivation, and another is the agriculture burning. So we are combined the three data set in Karnataka, and identification the both of the three sector, which district is the highest contributor and lowest contributor. You can see livestock is the animal, basically they are produce the lot of methane. So based on our data set, we have identification like which district is the highest contributor. You can see this is the provided the three sector, how much contributor of the every sector. Next slide. So I am coming to the methane emission inventory from livestock. So two sector is there. One is the anti-formation, and one is the manual management. So those are data we collected for annual like animal data from annual census data, and calculated to the our emission factor. Actually that type of bar graph is provided the animal wise, which animal can produce highest methane. You can see buffalo, like in Karnataka, buffalo is the highest contributor of methane. And that's why put it to the like animal wise methane emission in Karnataka. And based on our emission, you can see this is the map are showing Belgavi district is the highest contributor methane emission from livestock in Karnataka, and also Sivamongo and another district also, Mandya, all our district is the highest contributor the methane emission from livestock sector. Next slide. And based on our data set, we calculated to the different year, so we can analysis and future projection also. Those are that side technology are we can use for the reduction of the methane from agriculture sector. And this is the mitigation technology calculation, cost calculation, where those are is the available, we can use those Karnataka, how much cost is required for the if I reduce, how much benefit also government, how much benefit also profit also coming. That's is the economic slide. And another sector is the paddy cultivation. You can see also lot of paddy produce the methane emission. So we just focus the one like paddy cultivation area. You can see this is the red area, basically highly produce the paddy, and this is produce also highly methane emission also. And our data, basically based on the government data, they provided region-based paddy cultivation data. Based on our government data, we are using lot of parameter for calculating the methane emission from paddy cultivation in Karnataka. And similar way, we are identification the which district is the highest contributor and lowest contributor. And similar way, we are calculated like mitigation technology and cost-benefit analysis also. Next slide. So methane emission also similar way we calculated methane emission from agriculture residual burning. Similar way we calculated like black carbon type we have calculated, but here is we calculated on methane, only changes the emission factor and another factor value, and calculated for Karnataka level also. And those data is coming to the like similar way black carbon, but value is different because of the emission factor, all our parameter value is different. Next slide. and methane emission inventory for industry sector, and also similar we collected the emission, a lot of coal consumption and all data set or waste burning data set, industry waste burning data set from pollution control board, Karnataka pollution control board, then and put it to the model and generated the graded wise emission inventory for methane emission inventory from industrial sector. You can see this is the red pixel area is the highest contributor of the methane and in Karnataka, and also we are identification the Ramanagar is the highest contributor in, based on the industrial waste state, and another is the Mysore, and another is the also Kolburgi, and another also Uttar Karnataka is the and highest contributor of the methane from methane emission from industry sector. Next slide. And methane emission from road transport sector in Karnataka, similar we calculated we Bahan Poriman data and all our government data we are utilized for calculating the grid wise emission inventory. You can see this is the red area is the highest emission of methane, and also similar we prepare the mitigation technology, which can mitigation technology can reduce like lot of technology is there, electric car, electric bus, also driving cycle, smart city also they are starting, also avoided to the green infrastructure also prepare requirement, all are put to the mitigation technology. Those mitigation technology can reduce to the methane from transport sector also. Next slide. And another sector is the methane emission inventory from waste sector. Waste sector we are working 3 sector, like waste management and solid waste management, and also domestic waste water, and also industrial waste water. So you can see we are dumping location data we have collected from Karnataka government. Here is the dumping location. So you can see this is the pink color map. First map is showing the location of the dumping location in Karnataka. Based on the data set, we have a lot of parameter and emission factor is required, and also lot of parameter we have used for this calculation. And based on our data, it's showing like Bangalore urban, we just focused pink color point is the located of the dumping location, or the highest contributor is methane in Bangalore area. And also similar, we are preparing the mitigation technology and other analysis also. Next slide. So coming to the another part, this is satellite-based monitoring. Satellite also provided methane. Sentinel-5 directly provided methane data. Every day data is provided, basically satellite-based data. This is the, you can also require for the satellite data basically provided atmospheric data. You have to convert lot of equation and model for surface level. After we have calculated, you can see this is the red area is the highest contributor of the methane based on the satellite. And yellow pixel is the low area, and you can see white pixel is the some gap is there. This is water area. We just removed to the water area because of the not water area required for methane emission. And based on the, you also see this is the pattern also changing the methane in Karnataka level also. Next slide. Next. So coming to the where is the coming the red area, hotspot area, you can see all our agriculture area, farming area, and industry area is located those area. So also tourism area, all are basically highly produced like methane in Karnataka. You also is showing the time series graph. That side it is line time series graph. Every year is the increase the methane 10 also. Even like it is not reduced because of the source of the different. So increase every year. Also lockdown period also they in Karnataka also increase the methane 10 also. Next slide. Coming to the sector wise mapping, you can see we are preparing the sector wise mapping. This is the agriculture sector. You can see red area is the highest risk area. So based on the our put it the bar graph, we have classified like 5 category, very low to very high risk area. And you can see this is the Raichur, Kalburgi, and Belgavi, Badir, and another district is there. Basically all are highly methane emission in Karnataka from agriculture sector also. Next slide. I'm coming to the another like pollutant troposphere erosion. Tropospheric ozone is the secondary pollutant. First two pollutant is the primary pollutant, and tropospheric is the secondary pollutant because this pollutant is the basically three gas are mixing, basically NOx and VOC and heat and sun, and going to the atmosphere and prepare the ozone. Ozone basically highly affected to the health effect. You can know based on the ozone you have lot of disease, cancer, lungs disease, and also skin disease coming due to the ozone. So source of lot of source is there, industry source, burning source, and another also lot of source is there. So we are also working tropospheric ozone in Karnataka, monitoring in Karnataka. Next slide. So based on the our IPC guideline data set, you can see India level every year increase the tent. You can see this is the IPC part per billion the unit. Every year red area is the India first graph. You can see this is a very 99 is the very low tropospheric ozone, but every year you can see it is increased trend of tropospheric ozone in India level. Based on the IPC, they are telling the India and China highest contributor in South Asia country. Next slide. And in Karnataka, I am coming to the satellite-based monitoring because secondary monitoring data is not available for tropospheric ozone. Only satellite-based monitoring. Lot of satellite is monitor the tropospheric ozone and total ozone. True ozone is there on satellite data. One is the tropospheric ozone 0 to 15 kilometer, and 0 to 15 to 30 kilometer is the total ozone. So we are only monitoring 0 to 15 kilometer area. So this is the map. You can see this is red area is the highest contributor of the tropospheric ozone in Karnataka. So district is Uttar Karnataka is the highest, and coastal region is the highest showing. Anybody is telling like why not coming is the Bangalore area, why is coming to the Uttar Karnataka area is the highest? Any idea? Tropospheric ozone why is coming Uttar Karnataka is high? Why not coming to the Bangalore area, Bangalore urban? So this is secondary pollutant. All our gas are mixing upper atmospheric level, and also this area is the coastal area. Wind speed, wind direction all are high. You can see this going to the coastal area, wind direction and speed is the high. All are mixing the gas that area, and also this is the hilly area. All are mixing the gas and going to the atmosphere. That's why that area is the high contributor of the in Karnataka. And Bangalore urban is not coming. That's why is the coming not high area. Next slide. And you can see this is the coastal area and Western Ghat part hilly area. That's why is the coming. In the trend analysis, you can see this is the every year tropospheric ozone is the increased trend in Karnataka. Even lockdown period is not reduced. And every year you can see this one 18, 19, 22 graph we have put it that side. Every year is the increased trend in Karnataka level. So, so we have to proper way to mitigation technology is required for reduce the tropospheric ozone in Karnataka. Next slide. So another last parameter I'm discuss last parameter HFC, hydrofluorocarbon. It is also called the greenhouse parameter. It is basically coming to the AC, and lot of car and refrigerator you are using. Lot of HFC emission is produced. But we are not directly not monitoring. It is regional scale, it is very less amount is effect. But global scale, all are climate change, temperature increase, rainfall pattern change, all are due to the HFC parameter also. So lot of sources there, transport source and refrigerator, the supermarket, hypermarket, they are using lot of AC, and also residential AC, commercial AC they are using. Next slide. You just show this is the bar graph, pie graph. So you can see this is the which sector how much contributor in Karnataka. This is the like domestic AC and commercial AC and residential AC we have calculated, and also that graph is the provided which supermarket, hypermarket and grocery shop they are a lot of using the refrigerator, so they are produced the HFC. So we have calculated based on our data set. Next slide. So you can see based on our data set, you can just focus the Bangalore urban area. They are lot of like using the AC and AC from residential, and also high produce the HFC emission also. Based on our data set, we have calculated lot of parameter is required, leakage factor and another parameter emission factor, and also AC number and count number. Lot of parameter is required for calculating the HFC emission value. So you can see this is the which district is the highest contributor. You can see Bangalore is urban is the highest because of the everyone, and Mysore second, and third is the Dakshin Karnataka is the coastal area and also tourism area. Those are they are using lot of AC and produce to the HFC emission also. Those are the mitigation technology, that graph you can see, and this mitigation technology can use for the reduce to the HFC emission in Karnataka. Next slide. So another sector like HFC emission inventory from commercial AC. Commercial basically provided supermarket, hypermarket, grocery shop, and all are they produce to the HFC emission. So we are using Google API. You just searching Google, you just showing the where is the supermarket. Google Map also showing supermarket, hypermarket is located. So that technology we are using Google API for extracting the data set, where is how much is the supermarket located area and hypermarkets and also grocery shop. We are using Google API for extract the data set. You can see this map actually showing red area is the supermarket, and hypermarket, grocery shop we are put it every map, and Bangalore urban also put it there. Based on the data set, you can see we are prepare also emission inventory and HFC emission. We just focus Bangalore urban area, yellow pixel and red pixel. You can see this is the Bangalore urban area. Red area is the basically located at the supermarket and hypermarket. And that's why it's showing the highly HFC emission in those area. And our data also showing like Bangalore urban is the highest. Second is the Dakshin Karnataka, and Mysore is the third, is the HFC emission in Karnataka. Next slide. And another, this is the two methodology I discuss, and third I'm coming to the model-based monitoring. Model actually, a lot of model is there. NASA and NOAA is developed the air quality forecasting model, and a lot of satellite data and climate parameter is required. So we are using lot of 30-year climate data, rainfall, temperature, solar radiation, and all our data for satellite-based data we are using for WRF model. WRF basically weather forecasting model and developed by the NASA, and CAMEX and CAM is the chemical transport model. Basically using for the chemical parameter and physics parameter, all are required lot of parameter for this model for future forecasting. You are working like so we can predict the every hour pollution level like black carbon, methane, and future also. This data, this technology is required in Karnataka. Currently, we are MP also try to develop this technology. This technology also supercomputer, like lot of infrastructure is required, supercomputer, high-speed internet, and also lot of another parameter is required. So you can analyze those data set in Karnataka level and forecast for future also. Currently we are running this model, and this project is ongoing, and so we are running this model. Next slide. So we are this is US sponsor project. So we have lot of activity project like capacity building program and policy making program from government different sector. We are generated a lot of capacity building program with government sector, industry, and also university. All are MSc environmental science, climate change student also. We are discussed lot of government stakeholder, different like agriculture sector, industry sector for policy making for reduce the pollution in Karnataka level, and lot of publication we have done, high impact factor, urban climate, air, environmental pollution, all are LCVR publication we have done in this project actually. And next slide. And this is all our government meeting for preparing the policy for reduce the emission in Karnataka level. So we are currently preparing the policy and impose to the different sector to reduce the pollution by our data set. So government is working for policy making. Our institute basically provide based on the research. They are preparing policy, and policy can improve further action actually for government based action. Next slide. All our solution coming to the policy making require lot of policy for reduce the black carbon, also fulfill of the clean mission in government of India. And currently we are preparing policy making and try to the reduce the based on the policy you can try to the reduce the pollution in Karnataka level. Next slide. Thank you very much from my side. Is there any question? I'll sir. Just pass the mic. I think this is the technical part, really deeply research part. Okay.
Sir, already you spoke about not using the petrol-based vehicles and diesel-based vehicles. So we are turning towards EVs. So we see lot of industries are producing lot of environmental, environmental causing, harming gases towards
Mitigation technology and policy. All are we can based on the policy we can approach to the government. Government can take every districts and strictly action to the reduce the pollution and improve like mitigation technology for reduce the pollution actually.
So we can't completely ban EVs also, sir?
EV also pollute. We also on running project our under collaborate with IIT Hyderabad. After battery is destroying, lot of CO2 is coming. So that project we are also going running on project. How can also after battery pollution also after destroy the battery, a lot of pollution is coming. So we are also working that field also. So currently not a EV, another lot of mitigation technology is there. We can use those technology can reduce. It is depend on the awareness program and also depend on the people. You
Also, sir, we said that cultivation of paddy also produces methane. So how does that happen, sir?
this is chemical methane from paddy cultivation na for like defined chemical composition is there. So after chemical composition you are growing the paddy na, they are produce lot of methane. So methane directly going to the atmosphere from paddy. So that is the effect to the pollution also.
Thank you, sir.
Thank you.
As you said, industries which produce carbon and methane, you said mitigation methods, you will impose some policies on that. How much time is needed to implement it? Because when we have to take any mitigation method, you need complete difference in a very short time. Only people can recognize it if it is in very short time. This was there and now it has happened, so we'll take care of it.
Yeah.
But these small particles which are affecting health impacts for the people who are deciding decide. So what's your measure?
So for future scenario, India government Modi Sarkar also running the clean mission. They are the target into net zero goal. Net zero goal by 270 we have to reduce like 70% emission from industry and convert to the energy like solar energy and another energy sources and wind energy from energy sources also. So that's good. We are preparing like you saw the future projection also 2030 and 50 and Karnataka level. We are preparing future projection every year. We have data set. How much is the required is the every year reduction we have put it there.
We can't say no for industry, sir, to economical benefits. But economical benefits should not be at the cost of degrading health benefits of the people who are residing in the industries. No?
That's why we are calculating health benefit analysis. So how much they are working industry. Industry, a lot of people are working. They are polluted. They are affected. So how we are calculated the every day how much economic value is reduced if we health value is reduced in future also. We calculated 2030 and 50 also.
For the people who are working in the industry, what I am speaking is the people who are residing near the industries, small villages we can say, some sugarcane industries there, and surrounding 6 to 7 kilometers, whatever the standards
Yeah, that's why government also another project is greenhouse gas monitoring project. We are running 10 crore project, Karnataka government actually, the sponsor is the Karnataka government. Recently passed with the Vidhan Sabha actually, greenhouse gas monitoring in Karnataka. So we are preparing similar way like methodology and imposed to the like industry sector. They can use, must use this those methodology and reduce the emission also. Thank you.
Yes, sir.
Hello.
Actually, in one side, the data released by environmental management, one side, particular column, there was a technology. Another column was data results of surrounding us. So could you please name the technology which emits the black carbon and as well as it filters with it is own by its own technology? Is there any technology of such?
Yeah, yes. Lot of technology, there's not only emission inventory technology, satellite technologies, they are currently advanced technology, satellite, all are using satellite technology for gas monitoring and detection the gas.
I'm not asking about the monitoring, which release the carbon, black carbon, and it also filters by its own.
Filtering technology is there.
Like
Only,
direct air capture, if I'm not wrong.
there, mitigation technology is put it, there are lot of filter technology is there. So also car also lot of filter technology is there. So those technology we have put it for government. Government can decide it, which technology is required and not. Government board is there. We are not particularly recommended everything. They are decided
Because you
actually.
had mentioned
Yeah,
also that.
mitigation technology is there. Filter technology all are there.
Fine.
Okay, thank you.
Hello, sir.
Hello.
How can an individual contribute in eradication of pollution?
Individual contribution.
Uh,
Reduce. Okay.
reduce.
Uh, awareness program, like you have to decide, you show the all our data set, we are prepared, where is the methane is the highest contributor, you have to own step, reduce the emission also. Then not only government requirement, you have to own step.
Okay, thank you.
Is there any question? And from faculty side, is there any question? Put the mic.
Yeah, really, we are very happy to witness such an elaborated presentation. Uh, so I have a couple of questions. One is the inventory which you have done based on the satellite imagery. Okay. In what way you have made atmospheric corrections? Because some of the area showing the red in color, but it doesn't have any emission on spot.
Okay.
And second question is overall
Ah.
the pollution trend in Bangalore is declining after 2021. But your data is depicts the trend line is increasing.
Bangalore, which pollution is the decline?
Almost PM 2.5 is also decreased and the ozone is increased except other parameters.
You are talking to the air quality station based data?
Yeah, both the satellite imagery and ground-based data.
Decreased
I
trend.
want to know how you have the atmospheric correction.
But our government data actually provided 7-year data. They provided government based, station based data set. They are also showing increased trend. But some case located the basically satellite some error is coming, like 30% is I showing, I already told 30% is due to the atmospheric component, lot of effect the atmospheric component and the data pre-processing and analysis part, 30% error is coming. but 70% is accurate. And also we compare to the not only one satellite, we compare to the another ISRO satellite, also ESA satellite, also NASA satellite. Similar result we are got in, like difference is 10% variation is there.
And one more question asked by my colleague.
Yes.
How the methane is produced in the rice paddy cultivation area. As the presenter is already explained, the methane will be produced in the rice cultivation bed by the microorganism computation. So anaerobic digestion, organics are converted into the methane emission. And one more guy was asking how to mitigate the methane emission. Methane mitigation by the rice paddy, only thing you should avoid consuming the rice or avoid cultivating the rice. And not
Yeah. Hello.
Sir, is there any way to mitigate SLCP after we release to environment?
SLCP, all are parameter, 4 parameter. SLCP consider only 4 parameter. Not consider CO2, NOx, this is the another parameter. SLCP also short time period, but big effect.
Yes, sir, but the short time is not for few years. It's for few years.
Methane is 8 to 12 years. This is greenhouse gas also, methane. But black carbon only 4 to 8 days atmosphere movement.
Sir, any mitigation paths, I mean, ideas?
Lot of mitigation, different sector is lot of mitigation technology is there.
Yes, sir, there may be many mitigation methods, but it will not fully filter the pollutants, no, sir.
Here a lot of methodology is there. So you can use, we have put it for only Karnataka suitable technology, not on like based on the our US technology. We for only Karnataka can reduce which technology is available in Karnataka. Those technology can reduce to methane, black carbon emission. We have put it from our work actually.
That means we cannot adapt any technology.
Our technology.
No, sir. Is that the technology is limited for Karnataka?
Yes, sir. Technology for Karnataka. All our technology prepared for Karnataka actually.
what is the question is, there is any mitigation technologies available for Karnataka, you are asking, right? No, sir.
Lot of scheme in Karnataka, like diving scale, a lot of we converted to scale, band of the diesel engine car. Technology is the defined sector is the different technology is there. You can work in transport sector. Technology name. So that case we are government board is there. They are decided. We are put it to the technology to government.
Right, that's the question. What
Which
the
technology is
proposal?
there? Some transport sector. I going to the electric car, one option. Another also lot of filtering method is there. Technology also green infrastructure, roadside green infrastructure, and plantation also. Lot of technology. That type of transport I is talking about the transport. Another sector similar, waste sector also lot of technology is there.
So we will be talking about like how we can reduce our emissions. Like even that is also one factor which contributes to this, right? You see, emitters are we. We human beings, we are in these type of gases, right? Yeah. But what technology you are using for the remote sensing or data extraction?
Oh, you are asking remote sensing. This is the data analysis part, not mitigation technology. Mitigation technology is the defined. Okay, I talking. Okay, I understand. So we are using Google Earth Engine and Google Colab. Both are freely available for satellite data pre-processing, analysis, download, and this is cloud-based platform. You can everyone you can Google account. You can use Google Earth Engine. You search your mobile Google Earth Engine. All satellite data, NASA, ISRO, ESA, all satellite data day to day real-time data is available. You can data analysis part or tool, pre-processing tool, and programming part, data pre-processing, extract, and bias correction, atmospheric correction, and also like defined analysis, district-wise analysis, all a tool is there. You can analysis like freely available, but if you are working like big data, you have to purchase Google Earth Engine. Your area very small, like 80 GB, you are every day downloaded the satellite data. It's okay. They provided 80 GB. After you go into the 80 GB, they charges some. Google also charges some requirement charges also required. Google Colab also, you can, like Python, you can use this technology and use this, is all that satellite based technology is there. Hello.
How did you distinguish if it's methane or like any other gas or black carbon by
How do you?
She is asking how you are estimated different gas pollution using Google Earth. It's completely technical part. We need a separate seminar for this.
This is technical part. A lot of parameter is required. I'm talking to the lot of parameter. We are using lot of parameter, not only one parameter. Emission factor. Every car wise, different car is the different emission factor. We are using a diesel data set and also car count data set for also emission factor and another factor also lot of requirement. We are collected all factor and calculate the based on the IPC guideline. IPC basically provided international government agency. They are preparing. I also member IPC, and they are preparing for greenhouse and air, climate change methodology for government actually. Thank you. No, black carbon directly not provided satellite data. You have to calculate it based on the parameter. 3 parameter is required: AOD, aerosol optical dip, NOx and SOx, and also lot of climate parameter is required. They direct provided methane. Methane is direct provided satellite data, but black carbon not available directly satellite data, and ozone also directly available. PM 2.5 and 10 also directly not available. You have to calculate it based on the model based. Yeah.
By using technology, how can we convert unuseful industrial gases to useful in a useful way or good?
Oh, harmful gases to useful gases.
Eco-friendly gases.
Eco-friendly gases. This is defined technology. I am not going. I am not working this field.
Your concept is really appreciated because your concept is needed for present converting the pollutant gases into the non-pollutant gases. Okay. But the presenter is given the scenario of the Karnataka pollution emissions in different sectors. Okay. If you are a scientist, I hope you can do the project, research in future, help for the entire world.
Chemical part is defined. Our section also some instrument is there. They are working chemical lab also there. We have chemical lab also for gas fertilizer, greenhouse gas fertilizer analysis. Lab is there. So we have collected the sample also analysis the part also. This is instrument based part. Okay. Thank you.
Thank you very much, Mr. Narayan Kayat, sir. Sir explained about short-lived climate pollutants, sources of outdoor pollutions, and very important part is reducing pollution start with our effort only. So in such way, as environmental students, we should reduce, reuse, and recycle every material. That is the best thing what as an environmental student and guy can do. And next, I will hand over mic to Dr. Vinaya Chaitanya ma'am She is currently working as a coordinator in Department of Sustainable Development and Public Policy and Programmer Officer at Environmental Management and Policy Research Institute, Karnataka, Forest Department, Bangalore, with over 11 years of experience in teaching and research and advocacy programs. She holds Master of Science Geoinformatics and PhD in Marine Geology from Mangalore University. She got an opportunity to carry out her research work at Space Application Center, ISRO, Ahmedabad, and Indian National Center for Ocean Information Services at Hyderabad. She has also worked as a guest lecturer in research scholar at the Department of Geoinformatics at Mangalore University. Dr. Vinay Chaitanya secured first rank in Masters and obtained DST Women Scientist Fellowship. She also worked as a scientist B at Central Marine Fisheries Research Institute, Mangalore Center. Now, I would like to hand over mic to Dr. Vinaya Chaitanya ma'am for next session. Ma'am, mic over there. It will take 2 minutes. Before that, so just 1 minute activity. Can you do all as an environment student? So main 3 parts is 3 R's. 3 important parts are reduce, reuse, and recycle. So I will tell the actions. So what actions I tell now, you will repeat. Can you repeat all of you? Can you repeat? Can you repeat? Why no enthusiasm? Can you repeat? Okay. So I am also learner like you only. Okay. I will say reduce. Reduce means you should do like this. Okay na? Next I will say reuse. Reuse means you will do like this. Okay na? Next I will say recycle. Sorry, recycle means you should do like this. Reduce means you should do like this. Okay, are you ready? Okay. Please stand up for a minute. Ma'am? Reuse. Reuse means, so first one is, wait. First one means reuse. Okay, now so first one means reduce, then reuse, then recycle means this one. Okay, na? Are you ready? Okay, stand up. Stand up for 1 minute. Okay, are you ready? So first one, reduce, recycle, reuse. Very good. So once again, reduce, recycle, reuse. Very good. Thank you very much. Madam.
Thank you. So the first session was more technical, Dr. Narayan he spoke about all the research activities and all those things. So what I'll be talking is like simple terms, like it will be a sort of discussion. So if you have any inputs, you can say. So I'll be talking on climate change and sustainable lifestyle. So how these two things are connected. So next slide. So in this section, I'll be talking about like why we need to have lifestyle for environment, and I'll be talking on a scheme which we are promoting at N3, that is EIACP. Under that, we have Mission Life, Lifestyle for Environment, and goals and about SDGs. So next. Okay, so first, everyone, today I think you might have heard about the topic climate every now and then. I think we have told about that more than 100 times maybe. So can anyone distinguish what is weather and what is climate, or whether it is one and the same or two different things? So can anyone say yes? Climate is seasonal. Okay, one person is saying climate is seasonal. Is that true? No. Okay.
one particular area, and climate is on the whole place. He's saying weather is limited for one area, and the climate is. I'll get back to you, sir. There is a little bit correction. Yes. Yes, exactly. The climate is something which is, we are taking a long period trend that is over 30 years. That is called as any changes in the.
ಅದು ಮೂಮೆಂಟ್ ಇದ್ದದ್ದು ಕೊಟ್ಟರೆ ಒಳ್ಳೇದಿತ್ತು. ಇದು ಆಗಲ್ವಾ? ಇದಕ್ಕೆ ಆಗುತ್ತೆ? ಇದಕ್ಕಾಗಲ್ವಾ?
ಆಗಲ್ಲ ಮೇಡಮ್, ಅಲ್ಲಿ ಕ್ಯಾಮ್ರಾ ಇದು ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೌಂಡ್ ಸಿಸ್ಟಮು.
ಓಕೆ,
ವಿಡಿಯೋಗೂ ಕನೆಕ್ಟ್ ಆಯ್ತಿದೆ, ಇದರಲ್ಲಿ ಮಾತಾಡೋದು.
ಓಕೆ, ಸೊ
ಕೊಡಿ ಮೇಡಮ್.
I was comfortable going around and talking, but it's okay. So, as someone told, like the weather is climate is something which we have a long period trend over 30 years. What we are going to calculate, and then we see the anomalies, and then we say that there is climate change. Okay, what is weather? It is present state, that is daily fluctuations, that is called as weather change, and anything which is calculated over a period of time for 30 years, we term it as climate change. Next. So weather, it can change within hours or minutes. Okay, so you can say today it is sunny, tomorrow it may be rainy, or you can define it in any other way. But the climate is not like that. Climate is like something which you say, like for example, in the month of winter, the highest temperature, the lowest temperature 30 years back was around 25 degrees Celsius. But now the lowest temperature is 26 degrees Celsius. That is, you have 1 degree rise in the temperature. So that we can consider as climate change. Next one. So what causes climate change? Can anyone explain what causes climate change? I think we can circulate that mic. Oh, Vijay. Okay, can anyone? Okay.
Day by day, we can see the different kinds of pollution in our daily life, the emission of gases.
Okay.
We can see this one of the reasons for the.
Yeah, one of the reasons is emission of gases. That is, we have greenhouse gases in the atmosphere. So, you know, what is the main source of energy? Sun is the main source of energy. So we have incoming radiations, right? So we have incoming radiations from the sun. So these radiations will be absorbed and scattered. Okay, so you have incoming radiation as well as outgoing radiation. So these outgoing radiations, when you have more proportion of greenhouse gases in the atmosphere, it tend to be trapped within the atmosphere. So we need limited number of greenhouse gases in order to maintain the Earth's temperature, right? So when there are excess, that is more than the what is required, that those gases traps more heat within the atmosphere. That is the one of the reason why the surface temperature is increasing. Next one. So that's the reason the atmospheric temperature is increasing, because as the greenhouse gases are increased, the outgoing radiations are trapped within the atmosphere. That causes the climate change. Next one. Okay, so how many of you have visited coastal areas? At least you have seen coastal areas, most of you, right? Anyone who have not visited coastal areas? Okay, so why do you go to coastal area? For enjoyment, recreational activities, right? Some people may go for research purpose. Some people, I think 99% of us go for recreational activities, right? So we want our coastal areas to be in this condition, right? Where we can go, enjoy and come back. Next slide. So what we are seeing right now in the coastal area, not in this season, but in most of the rainy season, we have this scenario. That what you can see here. Can anyone explain what is this? Erosion, that is sea erosion. Okay, so we have more wave activity over there, and because of that, the has been increased. Okay, so Along with erosion, we have increase in the sea level also. So can anyone say why sea level is increasing? Okay, one is glacier melting. Okay. Global warming. So what happens when there is global warming? Sorry? Rise in temperature, atmospheric as well as the sea surface temperature also increases. So what happens when the water temperature increases? It expands. Okay, there is a process called as thermal expansion, right? So when you have thermal expansion, that is, it tends to have one of the contributors for sea level rise. So next one. So next factor which is impacting along our coastal area is cyclones. Cyclones, I think recently last week, there was a cyclone in Arabian Sea, somewhere in the coast of Iran, and there was one more depression in Bay of Bengal and Bangladesh, near Bangladesh. So we received 2 weeks back, I think 1 week back, we received heavy rainfall in coastal areas. So this is not a season for rain, right? So when we were in school, we studied, we had only 3 seasons, right? What are the 3 seasons? Summer, winter, and rainy season. But now we can experience all 3 seasons in one day, right? So this was not there. I think if you take 10, 15 years data also, if you remember, we had proper 3 seasons. But nowadays what we are experiencing, even in winter it starts raining, even in summer it starts raining. And when the proper rainy season comes, there is no rain for first 1 or 2 months. And after that, there will be rainfall, right? So our weather pattern has been altered. So next one. And also when we are talking about cyclones, one more thing is like we have 2 basins over here. One is Arabian Sea and one more is Bay of Bengal. If you take out the data, the number of cyclones were more in Bay of Bengal, if you take 10, 15 years data. But nowadays, even in Arabian Sea, the cyclones are increasing. That is one reason, is mainly because of increase in sea surface temperature. So because of that, the low pressure conditions are formed here in every now and then. And then the intensity and frequency of these cyclones are increasing. I think if you remember, in December, there was a cyclone which was formed in Bay of Bengal, and there was a landfall in east coast, and it traveled across the Indian subcontinent, and then it went to Arabian Sea. That is, it crossed from Bay of Bengal, Indian subcontinent, and then it went to Arabian Sea. That is the longest part where the cyclone can take, because most of the cyclone, when there is a landfall, after 1 or 2 days, it will get subsided. But this, it picked up the speed and it crossed the continent. So because of main reason is climate change. And one more reason, as I told you, we have 2 basins, that is Bay of Bengal and Arabian Sea. When we compare the surface temperatures, the Arabian Sea is much cooler compared to Bay of Bengal. So anyone knows the reason? Like why the water temperature in Arabian Sea is cooler than the Bay of Bengal. Bay of Bengal, the temperature is high. When you go and measure the sea surface temperature, it is higher. So can anyone say why? You know, the sea surface temperature is one of the factors which is fueling the our cyclones, right? So anyone? Any answers? See, we have major rivers in the west coast. So, in the west and east coast, both coast. But when we compare east coast, we have Brahmaputra. So, influx of fresh water from Brahmaputra is higher compared to our west coast of India. So, what happens? Most of the fresh water, since it is less denser, it tends to settle on the top layer of the ocean basin, right? So, we have thermal stratification. So because of that, the less saline and less dense water, it settles on the top layer of the water column. It tends to get heated up very quickly. So because of thus the sea surface temperature is higher in Bay of Bengal when you compare to Arabian Sea. Arabian Sea, we have lots of wind activity. Because of that, we have thorough mixing of the water column stratification. And these are the backwaters which we see. And this next one, sir. Sir, next. So this is the condition of backwaters right now. In most of the places, if you visit any place, you will find it can be anything, anywhere. So this plastics, mainly it gets into a river, like whatever the plastics you throw here. For example, if I eat a chocolate and I throw it away, so that particular small piece of plastic, it gets into a drainage network, it joins the stream and it joins the major river, and then it gets into somewhere in the ocean, right? So when we were doing our field work in Arabian Sea, mainly we used to go by trawlers to get water samples, sediment samples from somewhere in the mid of Arabian Sea, and we used to find their garbage patches in Arabian Sea. This might have increased right now because right now we are not doing any field, but as the scenario, in land only we can find so much of plastics, and in ocean you can find the percentage of plastic may be higher right now if you compare. So main thing, what happens in these river and marine environment when the plastics gets into these environment? One thing is you have one main thing is microplastics. So these plastics slowly it will be converted into microplastics, and there is a chain these fishes along with the phytoplanktons, they consume it as food, and who are the ones who are going to eat fishes? We are the ones, right? So it enters into the food chain. So that's the negative thing. And most of the, for example, in coastal areas, they, fishing is the main activity. So when they discard fishing nets. So these nets are very harmful to the fishes in the coastal areas, because there are turtles and other big fishes which gets caught into these nets. And next one slide. So next one. Okay, so what is this? Mangroves. So where do you find mangroves? Estuaries. Do you find mangroves here in Mysore, Bangalore, Western Ghats? Why so? What's the main environment, like what are the environmental factors required for mangroves? Can anyone say? Sorry? Okay, yeah, brackish water, yes. It is in the estuaries, yeah. Yeah. Pneumatophore? Yeah, one thing is one thing is about, it is found mainly near the coastal areas, estuaries, okay, where we have mix of saline and fresh water, right? So these are the unique ecosystem which you cannot find above the Western Ghats. It is only in the coastal areas you can find. And one more, the main, can anyone say why this is important? Why mangroves are important? See, you can say we are in Mysore. Why this? Okay, okay. One, she's telling that it decreases the flooding intensity. Maybe. Yeah, maybe. Yeah, next. Sorry? It reduces pollution. Okay, okay. One is like it is an area for carbon sequestration, right? So that's one of the ecologically productive zones, mangroves. And most of the fisheries are dependent on these mangroves. Most of the fish population, it is a breeding and nesting ground, even for migratory birds. So it acts as a filter. And one more important, the importance of this mangroves is it acts like a barrier between when there are cyclones. So when there is a cyclone approaching to the coastal areas, if there is mangroves, it acts as a barrier. So the cyclones, it hits these mangroves, the intensity of cyclone is reduced, and then there will be a landfall, right? So that the damage to the land So that's one more importance of mangroves. Next one. This is the condition of mangroves right now. This is the condition. If you visit any coastal areas, you will find this. That is, it is polluted with plastics. So these plastics, mangroves mainly, it is famous for its extensive root systems. And when we have thrown these plastics, so it gets caught in that area, and this is how it looks. And do you think this is good for our productivity will increase or decrease because of this? It will, obviously it will decrease. So majority of the fisher communities, they are dependent on fishing, right? So if we are not giving a sufficient environment for the fish development, what will be the scenario? Next one. So rivers, it should be filled with water, but what we are seeing right now, next one, it's dry rivers, right? Even beginning of summer, maybe in the January end, during the transition stage only, most of the rivers are dried up right now. And we are facing water problem everywhere. I think Bangalore last year we had terrible water problem in most of the areas. And even in Mysore, I'm not sure about Mysore, maybe even here also you may have water problems, right? So next one. So the farmers, we want them to have a greener field. But what is happening? Next one is dried up, or it may be exactly opposite of that. Maybe a drought condition or flooded condition. So that, any two scenarios we are seeing in this scenario right now. Next one. And about the fisherman sector also, because even these are contributing to the GDP. The fishermen, we want our fishermen to come back with boat full of fishes, right? But nowadays, sir, next one. Nowadays, everyone are either they are coming with the empty boats or less fish catch or with plastics. So plastics, as we have done the survey along the coastal areas, the most of the fishermen, along the fishes, they get more plastics in the ocean. So is it the good scenario? No, right? So who are responsible for these plastics? We might have thrown it here in Mysore. It might have joined Kaveri River and it might have gone to Bay of Bengal. You might have come to Western Ghats and you have thrown there something and it joined Netravati and it might have gone to Bay of Arabian Sea, right? So we are the responsible people for this condition. And also fish migration is also happening. One thing is like when the water temperature increases, see when the atmospheric temperature increases, what we do? We switch on fan, we switch on AC, and we get adapted to that environment, right? And what these fishes can do is like they can migrate to the cooler waters. So there are certain species which was found in the southwest coast, that is in the Karnataka, Kerala coast. Now you can find those species in Gujarat coast. And some species which are in the west coast, it is migrating to the east coast also sometimes. So these fish migrations are everywhere, it's happening. And one more thing is there are species which are not of that particular native, like maybe invasion of alien species we call. Just 2 years back, there was a species called as Kargil fish. In local language, they call as Kargil fish. It is Odonus niger. That fish was the dominance was more in the coastal areas, especially in the west coast. Most of the fishermen were getting only Odonus niger or Kargil fish. So that was treated like a pest in the coastal areas. There were no other fish populations were declined because of the surging of that fishes. That is one reason is maybe change in the current direction. It was found somewhere in the reef areas, and because of the changes in the current direction, it moved towards the west coast. So that's one of the reason why these fishes were more. Next one. Have you seen this picture or have you visited beaches to see this at night? So in coastal areas, one more factor is this. This is like we call it as beautiful looking disaster. It is not good for our environment. These are bioluminescence bloom. Okay, so there are phytoplankton blooms, when the nutrients are more. That is, influx of nutrients are higher because of the factories or any other source. So the nitrate, phosphate, silicate content in the water was higher, and the phytoplankton blooming took place. And because of the release of certain chemical, there is bioluminescence. And this is not a good indicator of an environment. So it's majorly, this causes reduced dissolved oxygen. Because of that, it will decrease the fisheries in that particular area. And also these phytoplanktons can be toxic. And these toxic phytoplanktons will be consumed by the fishes, and in turn we consume it. And in most of the coastal areas, there are reporting saying that after consumption of these fishes, people felt sick and they got hospitalized, and there are many incidents along the coastal areas with this. And 2 years back, almost from Karwar up to maybe up to Kasargod region, there was lots of blooming, bioluminescence blooms, which we found along the coastal areas. And even at night, the beaches were flooded with people. Like how people used to go in the daytime, people used to go to beaches tonight to see this disaster. This is also a man-made disaster, which is not a good indicator of our environment. Next one. And roads, everyone want developed, beautiful roads, but next one. But what we see in the roads is this. Every corner of the road we find. I think in Mysore, I think it is less because it's termed as one of the cleanest cities. I think now we are in second place, I guess. The first is Indore. Yeah. So in Bangalore, every road, each corner of the road, you can find this scenario. Not in Bangalore, everywhere. Recently, we visited Raichur. Raichur is full of plastics, I can say. So main thing is we are responsible for this, because every day municipal collectors, they come to our place to collect the waste, right? But we are lazy to get up early, or we are lazy to go down, or their timing may not suit us also. That's also one scenario in the working sectors where we are getting concerns of that also. So that may be one of the reasons why people are, or else there may be a less awareness. Like what happens, they'll say only, there is a saying like 1 million people told that it's just a single plastic. That means 1 million plastic has been thrown out every day, if 1 million people says this. Next one, sir. Okay, this is a bird which is found in a remote island in Pacific Ocean. Okay, so this bird, mainly what you can see in the stomach of this bird is plastics. There is a documentary you can watch on Netflix about this particular bird, like how plastics are reaching that remote island, and how these birds think it as food and they consume it. And most of the mother birds, they go and get food for their small ones, like for little ones. So these mother birds think that it is food, and they get that plastic and feed into little ones. So what happens, it doesn't get inside the throat. It gets congested, and they suffer, they die because of that plastics. So you can watch this video, even in YouTube also you can find this documentary. Next one. So Western Ghats. Have you visited Western Ghats? Here we have sir who is working on Western Ghats in Shimoga area. So Western Ghats, it's one of the, again, one of the most ecologically productive zones where we need to, because most of our living is dependent on Western Ghats. Without Western Ghats, we are nothing. But what is happening to our Western Ghats? Next one. This has happened to our Western Ghats, right? You remember 2018 Kodagu floods. Even recently we had, in 2024 also we had a scenario. So what happened in 2018 in Kodagu? Can anyone say? Landslides, yes. So what was the reason for landslide? Deforestation, okay. Changes in land use, land cover pattern, right? So in Western Ghats, we have Shola forest, right? So these Shola forests, these are grasslands which have been replaced with the, and also the native species have been replaced with plantations, right? Any sort of plantations in the Kodagu areas. And also there were agriculture field. Agriculture field was like, it was moist, watery field, and that has been converted into construction sites. So most of us, we have Instagram. When we open Instagram, we get reels about some jungle resorts or some development in middle of the forest areas, which is, I think sir will be the most appropriate person to talk about that, like about the encroachments in in these sectors. So what happens when there is a change in land use, land cover pattern, the soil will lose its stability, right? So when you are replacing the native vegetation with some invasive species, which is not of that particular area, that will act as a threat to that particular environment, right? So it has impacted human beings, and also it has impacted the small streams which is flowing in the Kodagu region. So I've read a research paper which says that there were certain streams which was flowing towards Arabian Sea. But after this disaster, those streams are joining Lakshman Tirtha, and it is Kaveri, and it is joining Kaveri, and it is flowing towards Bay of Bengal. So that's how the impact of these disasters are. Next one. So this is Shirur. I think everyone are aware of this, which happened recently. And next one is about Wayanad also. Because of the dense cloud formation, and there was heavy rainfall all of once, and overnight the village was washed off. So that's one scenarios what we are seeing along the Western Ghats region. Next one. So why do we need our carbon dioxide? But now Mangalore is terrible. If you go to Mangalore, you can't sustain. You feel like it is too much. So I think after 10 years, it will be the same scenario what we have right now in Mangalore, you will have it in Mysore. After 10 years, if we continue the emissions at the same rate. Next one. And also we have, our target was like by 2050, there will be rise of 1.5 degrees Celsius. That was the target which was set. But they say that by 2030, we will be reaching this target, that there will be 1.5 degrees Celsius rise in temperature. So you can see what will be the future which is lying ahead of us if we don't take any actions right now. Next one, sir. So one more thing somebody told about glacier melting also. So glacier is melting about 10 times faster than the current, what was the rate before. Mainly because of the global warming, the increase in surface atmospheric temperature. Next one. And as I told you about sea level, this is a prediction of Kochi area. You might have aware of geography of our Kerala. So in Kochi area, if there is 2-meter rise in sea level, what will be the scenario? You can see it in red color. So most of the places will get submerged. Next one. As the temperature increases, we may face water problems, water scarcity problem. Next one. So it may be, say, all activities are directly contributing to our GDP, right? So there may be a decrease in GDP. So we are promoting Mission Life, that is Lifestyle for Environment, which is a scheme of central government. Where we are promoting people to change their lifestyle. These lifestyle doesn't come with the cost. Like it need not have heavy investment or something like that. So as morning, I think Dr. Rasha was talking about our, and also Dr. Chandrasekhar, they were talking about the traditional values what we had before. Like what were the practices which are followed by our parents or our grandparents, which we are not following.